Okay, so let's look at this example using a recycle stream. So we have 100 kilograms of wet material coming into our dryer, and it starts with a moisture content of 15% water, and it's going to come out as 7% water. And what we want to know is how much water is removed, how much dry air was in the fresh feed. So dry air is not the same as fresh air feed, right? Dry air is air without water, but if it comes from outside, it contains water. And then we also want to know how much dry air is in this recycle. We have information about humidity given below. This was in the original drawing, written in on the drawing, and I just found it unreadable. So this stream here has 0.01 kilogram of water per kilogram of dry air. That's the air without the water. 0.03 kilograms of water per kilogram of dry air is in this stream that's the feed to the actual dryer. And the recycle is 0.1 kilograms of water per kilogram of dry air. So let's now look at work. So remember, we want to, use our good practices. So we want to be able to take this stuff and first complete a materials table and then do a degrees of freedom analysis to get started. Now, remember that one of the things that I need to keep in mind is I've got 2 extra units here. Okay, I have here a mixing point and here a split point. A split point, remember, the composition of these 3 streams will all be the same. So as I fill out my table, that's going to change the way I interpret some of this information. And in particular, streams 5, 6, and 7 have the same information. And down here, I have stream 7. This also, therefore, applies to streams 5 and 6. Okay? So I've written these as process specs because they're not exactly mass fractions, although they're clearly related to mass fractions. But they're not going to really fit into the table directly. I have them for 3, 4, and 7, but I know because of my definition of a split point that it's also going to be true for streams 5 and 6. So let's start filling in this table here. Now sadly, the only stream I know flow rate for is the wet material coming in. That was 100 kilograms, so I will choose that as my basis. 100 kilograms and 1 is going to be my basis. At this point, I don't know any of the others, so I could label them as F2, F3, F4, F5, F6, and F7. It's not very helpful, but I can certainly do that. And then I want to come up with compositional information. What was given was 15% water coming in for stream 1, 7% coming out in stream 2. There's not going to be any air there. Now this is an assumption, but it's very reasonable that I don't have air mixed in anymore with these streams. So therefore, I can add in my head and know that if it's 15% water, it must be 85% everything else. And similarly, if stream 2 is 7% water, it must be 93% those solids. Now over here on this part, these are the streams up here where I have my air and my recycle. So I have 1, 2, 3, 4, 5 of these streams that are air with water in them. They don't contain any solids. So the material, the dry material, is going to be 0 in all of those streams. There is going to be air, there is going to be water, and sadly I really don't know how much. It's all embedded here in this information. So this is X3. Okay, I don't want to use all those subscripts, so I'm going to use a notation where X is going to be my mass fraction of water, and Y is my mass fraction of air. Now you can use any notation you want, but it's helpful if you're using something that's not standard to kind of make a note of it someplace of what your notation is, okay, so that people can have a, fighting chance at following your work. So if this is x3, I'll call this y3, and this is x4, and this is y4. Now remember these are all going to be the same. So what do we want to call them? 5, 6, 7, it really doesn't matter. I guess since this down here, my process spec, is given in terms of stream 7, let's say this is x7 and y7, x7 and y7, x7 and y7, 7. Okay? So I have that information, and I've used my knowledge of split points in order to help simplify my table here. Now let's come down and look at our degrees of freedom analysis. Okay? So I'm not going to be able to write in all the list of variables, just simply space allowances. But what I have is my possible balances I can write. These are my various units. I have the dryer itself, which is right here. So it's going to be streams 1, 4, 5, and 2. I'm going to have my mixing point over here, which is streams 3, 4, and 7. I'm going to have my split point here, 5, 6, and 7. And then I also want to look at the combination. Here the only combination is if I just take a big block over all of this, then I have streams 1, 2, 3, and 6. Okay? So let's start filling this stuff out. Let's look at first the dryer, which was stream 1, stream 2 came out, 4 came in, 5 came out. Okay, I'm only looking at what's just right here around the dryer. Okay, so the variables there, I have F2, I have X4, Y4, F4, X7, Y7, F7. So I have 1, 2, 3, 4, 5, 6, 7. Okay, and remember you can list them here. I just don't have space on these little slides. Now what material balances do I have? I can do a material balance here on the material, the solid material, the water, and the air. So I have 3 material balances. And sum of x, I look in each stream and see if I have unknown x or compositions. Not here, not here. I do there, so 1. I do here, so 2. Now process specs. This is where I look down here and see if any of these apply. So 1, no. 2, no. 4, oh, yep, 4 is right there. And 5, this applies to 5 and 6. So I have 2 process specs. So I have 7 equations, 7 unknowns. My degrees of freedom is 0. So I actually have enough information. I could go ahead and work the problem, but let's go ahead and do all of these others just so that we have good practice at this. So my mixing point. This is the mixing point right here. The recycle is brought back in together and comes in here at the mixing point. So stream 3 comes in, 7 comes in, 4 comes out. 3, 7, 4 comes out. Okay? So my variables in those streams, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. How many material balances do I get? This is all air. There's only air and water. There's no material, no solid material there. So I get 2 material balances. But each of them does involve unknown compositions. So I have 3 sum of x equations. And process specs, I have a process spec for every one of them. But this still leaves me with 1 degree of freedom. So this one isn't ready to be solved yet. That doesn't have enough information. Let's look at the split point. Now the split point is streams 5, 6, and 7. So 5 comes in, 6 and 7 come out. All right? These have the x, y, and a flow rate for each one of those. So 5 variables. Okay, remember all of those are the same x's and y's. Again, I do have 2 material balances. Sum of x equals 1, I have 1 of those because it's all the same pair. And process specs, I have 1 of those, leaving me with 1 degree of freedom. If I look at the overall, when I look at the overall, remember that what I want to do is I want to basically draw a box around the whole unit, okay, and pretend that none of that happened. Okay, can't see it anymore. All I have is 3 and 1 coming in, 6 and 2 coming out. Okay, so 1 and 3 in, 2 and 6 out. Now if I look at those, 1 has no unknowns, 3 has 3 unknowns, no, 2 has 1 unknown, so I'm up to 4, and then 6 has 3 unknowns. So I have 7 unknowns. Now how many material balances here? Because this involves this wet material coming in, I have materials, the dry solids, I have water, and I have air, so I have 3 material balances. In these streams, 3 contains unknown x's, and 6 contains unknown x's, so I have 2 sum of x equations. Okay? 3 and 6, I have process specs. So I have 7 equations, 7 unknowns, I have 0 degrees of freedom. So I can solve the overall or the dryer, and I can do it in either order. So let's go to, now I've chosen, just arbitrarily, okay, that I'm going to do the overall first. Okay, where we're ignoring all of that. Okay, so if I do this, I have, first of all, okay, so let me write down what we're doing. I could do a total material balance, because that's usually an easy one. So in the total material balance, 100 comes in, okay, F3 comes in, F2 and F6 come out. I also could do solid material balance. Sort of weird sounding, isn't it? Okay, and remember it was 85% of stream 1. There are no solids in stream 3, and it's 93% of stream 2, and no solids in stream 6. Okay? So if I did that, I actually at this point have enough to solve for F2. It's going to be 0.85 times 100 divided by 0.93, and I learned that the dried product is going to be 91.4 kilograms. Okay, so I now actually have one of my values, and I could come up here and replace that. Every time you have something known, it is helpful to write it in, so now I can see that, oh, that only has 2 unknowns in it. Okay, so what if I wanted to come over and do one of these others? I can do either air or water. Water's in all the streams, so I'm going to choose the air one as my other equation. So air, I have, well, no air coming in stream 1. I have x3 times f3 coming into stream 3. I have no air coming out of the dried product. And I have x6 times y6, not y6, f6. Oh, these are supposed to be y's, aren't they? Okay. Air was, no, those are, yeah, y's. Let me just erase that and make it pretty so you can tell what on earth I've written. Okay, a little bit better there. Now, this equation and this equation are perfectly fine equations, but they're not really very helpful yet. So let's start using these process specs. Oh, I have a sum of x equation, okay? It says that x3 plus y3 equals 1, and I have a sum of x equation x6 plus y6 equals 1. Guess those are also 5s or 7s. Okay, so I mean, I have those equations that are also not helpful yet. Okay, what if I look at those process specs? Been kind of itching to use those, right? They're so weird. What do they mean? Okay, well, the process spec is the mass of water divided by the mass of dry air in any particular stream. So if I did this for stream 3, what that says for stream 3 is, okay, let's do kind of like a little mini basis here. Well, no, we'll just multiply by the flow rate. Okay, what's the mass of water in stream 3? Well, that's going to be x3 f3. And the mass of dry air in stream 3 is y3 f3. Now the f3's are going to cancel, so see, that's no big deal. x3 over y3 is equal to that 0.01 kilograms of water per kilogram of dry air. Okay, now this is still complicated, but if I combine these two equations, now I've got something I can work with, because x3 is 0.01 y3. So 0.01 y3 plus y3 equals 1. This equation becomes this. So y3 is 1 over 1.03. Okay? And, well, I calculate that over here on the side, and I just accidentally turned off my stuff. And it's not, how about, that's a 1, isn't it? Okay. You guys noticed that before I did, I bet, huh? Okay, so 1 over 1.01. And when I do that, I get, well, okay, 0.981 roughly. Okay, and x3 is 0.0099. Okay. Now I could do the same thing for this stream here, which is 0.1. So similarly, x 5 or 6 or 7, whichever one you wanted to do, x6 is going to be 0.1 y6. 0.1 y6 plus y6 equals 1. y6 is 1 over 1.1, okay, which is going to be, what, 0.91? And x6, oh, so out of space, is 0.09. That's a 9. Okay. So I have the x and the y information about these streams here, okay, leaving me with this equation. Let me change colors here. Okay, where I now know these numbers here. Okay, 0.981 and 0.91. Okay, I could solve for F3, plug that in here. Okay, I need more paper, so let's, okay. So I end up with, okay, the fresh air coming in, so F3 is 96.5 kilograms, and F6 is 105.1 kilograms. Okay. Now, what do I want to do next? I've got several choices. At this point, I actually am going to have enough information to solve several of these other things, but let's just go ahead and, since we're kind of on a roll with working with those process specs, let's look at stream 4 again. I actually do know compositions there, correct? Right? Because what I know is that if so the process spec for stream 4, what I know is that 0.03, and that was the one I was trying to use earlier, right? Okay, kilograms of water per kilogram dry air. Okay, so that's X for F4 over Y for F4. F4's cancel, so I end up with X4 is 0.03 Y4. I also know the sum of the x's equals 1 for stream 4, and so x4 plus y4 can now be written as 0.03 y4 plus y4. That's going to equal 1, so y4 is 1 over 1.03, and x4 is going to be 0.03 over 1.03. Wow, suddenly having a hard time writing. Okay, so 0.03 divided by 1.03. Oh wow, okay, so there's something wrong with my calculator. It just keeps giving me 0 no matter what numbers I plug in. Okay. One divided by, oh. Okay, so I now have the fractions that are going in each of those streams. Okay, so now then, what do you want to do next as your work? We could go back and do the dryer. Okay, I know all of the mass fractions. I know that the mass balance, the overall, is going to be F1 plus F4 equals F2 plus F5. Okay, I know this is 100. I know that my dried product, it was on the previous page. Let's see if I can find where we had that. That was 91.4. Okay, so I've got two unknowns there. I could do either an air or a water balance on each of these things, but whichever one I choose to do, it's going to be, if I do air, because it doesn't show up in the other streams, Y4, F4 is going to equal, how about Y 5F5. Okay, I know the numbers here for those from this page and the previous page. I have an equation here, so I can say that F4 equals Y5 F5 over Y4. Plug that in here. I now have only one unknown. By substitution, I can solve for F4. I could then solve for F5. We could go through and we could finish all of this, getting the necessary numbers, but it doesn't answer my questions. Okay? So now let's finish the problem by answering the questions. Okay? So what I have right now is that I have, this was 91.4. Coming back in, and let me write those numbers in that we had earlier. Except they're not there. Okay, I've got, this one is 96.5, this one was 100, trying to find all my numbers, sorry. Okay, 96.5 here. 105.1 here. Okay. I end up with, the recycle is 30, going through and solving all those equations that we had there. Do I have the number for what goes, well, okay, 30 plus 96, 126.5. That doesn't make sense. That has to be 96.5. So oh, 96 point. That's the one that's wrong. That's okay. That's 126.5. This is 126.5. Okay, now we can answer the questions that were originally asked. Okay, so what they had asked was how much is going to be, how much water is removed. Okay, so came in with 0.15 times 100. Okay, that was my water in. The water out came out as 0.07% of 91.4. And if I subtract those, so that's my water out, the difference between these is how much is removed, and that is 8.6 kilograms of water removed. Okay. Now the next question is, how much dry air was in the fresh air feed? Well, we actually have that information, just that we have it as percentages. Okay, so we want we want Y3 times F3. Okay, that's how much dry air is in the fresh air feed, and that comes out to be 95.5 kilograms of dry air. There's 96.5 kilograms of moist air, 95.5 kilograms of dry air. And then again, how much dry air is in the recycle? Well, we have Y7 times F7, and that turns out to be 27.3 kilograms of dry air. So again, I just want to keep reminding you over and over again that frequently we do all of this math, you feel like you've finished the problem, I've solved all the equations, and then you need to come back and answer the questions. Okay, because the questions used that information, but it wasn't exactly that information. Okay, so this completes our study of material balances without reaction. In our next set of lessons, we're going to be looking at what happens when we have reactions.